Hello students, hope you are doing well. In this video, we are going to discuss Enterprise Edge WAN Technology Part 2 of Unit 4, Designing Remote Connectivity for the subject, Enterprise Network Design of B7 Semester IT University of Mumbai. In this video, we are going to discuss WAN Transport Technology, that is coming under Part 2 of Enterprise Edge WAN Technology. Part 1 is already completed in previous lecture and Part 3 we will discuss in next lecture. In that Part 2, WAN Transport Technology like TDM, ISDN, frame relay, asynchronous transmission mode, MPLS, macro Ethernet, DSL technologies, cable technologies, wireless technologies, SDH, SON, dense wavelength division multiplexing and dark fiber will be discussed. So let us start. WAN transport technology. This table compares various WAN technologies based on main factors that influence technology selection. This table provides typical baseline characteristics to help you compare the performance and feature offered by different technologies. Offering of services provided limit your technology decisions. So let us see. In this technology comparison, bandwidth is one factor, latency and jitter is another factor, connect time is factor, tariff is factor, initial cost and reliability, these are the factors. So when comparing these technologies, if we use high bandwidth, if we want to use high bandwidth, then SONET, SDH, DWDM and dark fiber are the best among all the technologies. While we are going to low to mid range of these technology, then DSL is the normal modem which in earlier days we have already used. Okay, before 4 to 5 years back we have already used DSL, and nowadays also some of the internet providers provide DSL modem. And then macro ethernet is also there in fashion, so it is coming under medium to high bandwidth. MPLS is also a medium to high bandwidth. ATM also support medium to high bandwidth, while frame relay and ISDN technologies are supporting low bandwidth. In case of TDM, that is leased line, it supports medium bandwidth. So if we choose bandwidth as a main consideration, then SONET, SDH, DWDM, dark fiber, these are the main technologies which is recommended if you want more bandwidth. If we consider latency and jitter, then very low latency and jitter is found in SONET, DWDM, and dark fiber. While frame relay also supports low latency and jitter, ATM also low latency and jitter, MPLS also with low latency and jitter. ISDN is not recommended, and DSL cable modem and wireless, these are technologies also not recommended while considering latency and jitter. If we take connect time as a parameter, then this ISDN only requires more time, okay, medium time, but all other technologies that supports very less connect time. Okay, so ISDN is not recommended here with respect to connect time and latency and jitter also. Now come to tariff. Tariff is low for DSL, that's why normal user chooses DSL cable or DSL cable modem, while the SONET, SDH and DWDM, these technologies require medium tariff plan. It is coming with medium tariff plan, but nowadays it is also very easy to available by Geo and some other companies. Okay, some private ISPs are also available who provides these fiber backbone with very less amount. Okay, in case of TDM, ISDN, these are traditional technologies and often come with medium mid-range tariff plans. Okay, because this particular topic is, if we consider this topic, so the book recommended uses 2008 references. So in the year 2008, whatever will be the respected parameters, it is considered here. Initial cost is medium for TDM, but for ISDN it is very less, and for other technologies this is medium, and for DSL also it is low. So that's why most of the time the DSL technology is recommended. Okay, and that's why the normal public is using this DSL cable. Now come to reliability. Reliability is also medium in case of DSL, and very high reliability is given by provided by the ATM and MPLS and also Metro Ethernet. While the three technologies TDM, ISDN and frame relay is medium reliable, when we consider optical channel, that it is very highly reliable kind of technology. Now come to TDM or lease line. So let us discuss one by one. TDM is a typical digital multiplexing in which pulse representing bits from two or more channels are interleaved on a time basis. Rather than using bandwidth only as required, TDM indefinitely reserves point-to-point connection bandwidth for transmission. The base channel bandwidth is 64 kbps, okay, per second, 64 kbps or kilobit per second. It is also known as digital signal level 0 or DS0 technology. Why it is DS0? Let us discuss. And this 64 kbps is bandwidth required for uncompressed digitized phone conversation. Uncompressed. Okay, that is very important thing. And already seen that TDM technology is also known as leased line with medium mid-range bandwidth and low latency, and jitter. Connect time is also low, tariff is medium, initial cost is medium, and reliability is also medium. So let us now discuss DSO 0 rate. What is DSO 0? DSO 0 is digital signal level 0 rate. Standard speech is typically below 4000 Hz. Analog speech is therefore filtered at 4000 Hz. Okay, before being sampled. The Nyquist theorem states that a signal should be sampled at a rate at least twice the input frequency to obtain a quality representation of signal. Therefore, the input analog signal is sampled with 8000 times per second, and each of the sample is encoded into 8-bit octet. Fine. The DSO rate is therefore 8000 samples per second times 8-bit per sample, which is in result of 8 multiplied by 8000, that is equals to 64000 bits per second or 64 kbps. Therefore this bandwidth is coming, or DSO 0 or DS0 signal level is coming. Fine. So this is the result why TDM uses 64 kbps. Now come to ISDN. It is a system of digital phone connection that has been available as a communication standard since 1984. This system allows voice and data, integrated voice and data, to be transmitted simultaneously across the world using end-to-end digital connectivity. End-to-end digital connectivity. ISDN connectivity offers increased bandwidth, reduced call setup time, reduced latency, and lower signal to noise ratio compared to analog signal or analog dial-up. However, because the industry is moving towards using broadband technology such as digital subscriber line, yes, it is very important that DSL is broadband, cable, and public wireless to IP security, IPsec, VPN. ISDN presents an effective solution only for remote user application where broadband technologies are not available. Nowadays it is very available, but in 2006, 2005, that time this ISDN is widely used technology. Okay, and this is up to 2010, maybe 2013, this is widely used technology. After the emergence of DSL technology, it is thrown out from the technology. Analog modem dial-up, also called plain old telephone service. Plain old telephone service provides data connectivity over PSTN using analog modem. Dial-up supports relatively low speed connection compared to broadband technology. Dial-up point-to-point service is typically no longer a cost-effective solution for WAN connectivity. It might be cost-effective only as a backup access solution for internet connectivity in teleworker environment. So this ISDN is not recommended nowadays after emergence of DSL technology. Now come to frame relay. This was coming into existence from 1980s. Frame relay is an example of packet switch technology. Packet switch technology. So this is packet switch technology for connecting devices on a WAN that has been deployed since the late 1980s. Frame relay is an industry standard networking protocol that handles multiple virtual circuits. So it handles multiple virtual circuit. That is very important thing, using a derivation of high level data link control HDLC protocol encapsulation between connected devices. Frame relay network transfers data using two connection type, that is, one is PVC, which are permanent connection. PVC is permanent, pure virtual or permanent virtual connection circuit. Then SVC, which are temporary connections created for each data transfer. Okay, this is created for each data transfer and terminated when data transfer is complete. And this SVC is not widely used. Now come to ATM. ATM is layer 4 entity, and the unit of transfer of data is known as cell. It is fixed in size, 53 byte long. Each ATM cell can be processed asynchronously relatively to other related cells. Queued and multiplexed. This is queued and multiplexed over transmission path. ATM provides supports for multiple quality of service classes to meet delay and loss requirement. Okay. MPLS, multi-protocol label switching. So this MPLS is an Internet Engineering Task Force standard architecture that combines advantage of layer 3 routing with the benefit of layer 2 switching. Okay. With MPLS, short fixed length labels are assigned to each packet at the edge of the network. So here you can see the packet. Okay, different packets are there and the labels are also associated like 19, 21, 17 and so on. So these packets are assigned with particular label. Rather than examining IP packet header information, MPLS node use this label to determine how to process the data. This process results in faster, more scalable and more flexible WAN solution. The MPLS standard evolved from effort of many companies including Cisco's tag switching technology. Cisco's tag switching technology. Okay. MPLS enables scalable virtual private networks, end-to-end quality of service and other IP services that allow efficient utilization of existing network with simpler configuration and management and quicker fault correction. So let us now discuss MPLS operation. MPLS is connection-oriented technology whose operation is based on a label attached to each packet as it enters the MPLS network. A label identifies a flow packet, for example, voice traffic between two nodes, also called forwarding equivalence class, FEC, forwarding equivalence class. Okay. So an FEC is a grouping of packet belonging to the same FEC receive the same treatment of the network. The FEC can be determined by various parameters including source or destination IP address or port numbers, IP protocol, IP precedence, or layer 2 circuit identifier. Therefore, the FEC can define the flows quality of service requirement. In addition, appropriate queuing and discard policy can be applied to FECs. The MPLS network node called label switch routers, LSR, label switch routers. Okay, these routers are very important. Use the label to determine the packet's next hop. The LSR do not need to examine the packet's IP header, rather than they forward it based on the label. After a path has been established, packet destined for the same endpoint with the same requirement can be forwarded based on these labels without a routing decision at every hop. Labels usually corresponds to layer 3 destination address, which makes MPLS equivalent to destination based routing. A label switch path, this is label switch router, then label switch path is also one of the technologies, must be defined for each FEC before packet can be sent. It is important to note that labels are locally significant to each MPLS node only. Therefore, the nodes must communicate what label to use for each FEC. One of two protocols is used for this communication: the Label Distribution Protocol, that is LDS, Label Distribution Protocol, or an enhanced version of Resource Reservation Protocol. An interior routing protocol such as Open Shortest Path First, OSPF, or Enhanced Interior Gateway Routing Protocol, EIGRP, is also used within the MPLS network to exchange routing information. A unique feature of MPLS is label stacking, in which multiple labels can be carried in a packet. The top label, which is the last one in, is always processed first. Label stacking enables multiple LSPs to aggregate, thereby creating tunnels through multiple label at MPLS network. In this figure, an MPLS label is 32-bit field, okay, placed between a packet's data link layer header and its IP header. So this figure shows flow of two packets through MPLS network. Here, each of the MPLS node has previously communicated the labels it used for each of the defined FECs to neighboring nodes. Packet A and packet B represent different flow. Okay, packet A and packet B represent the different flow. Here packet E, packet B, packet B, packet B, and packet A, packet A, packet A, packet A, and packet B. These shows the different packet flow. And for example, packet A might be from FTP session, whereas packet B is from voice conversation. We can as means it is coming from FTP, file transfer protocol, and it is coming from voice. One is data channel and other is voice channel. These packets would take the same route through the network. For packet A and B, router V is ingress age LSR, that is the point at which the packet enter the network router and network at router V. Okay, so router V examines each packet and determines the appropriate FEC. Packet A is assigned label 17 and is sent to router X. So label 17 is sent to router X. This is the router X. Fine. Packet B is assigned label 18. Packet B is assigned label 18 and is sent to router W. Here it will be forwarded. As each LSR receives a labeled packet, it removes the label located the label in its table, applies the appropriate outgoing label, and forward the packet to the next LSR in the LSP. When the packet reach router Z, when the packet reach the router Z from V to Z, if V is ingress router, the egress age LSR, this is egress and this is ingress. Okay, so there are two routers. So in this egress router, or the point at which packet leaves the MPLS. So here packet leaves, here packet combines. Packet arrives and here packet leaves. So router Z removes the label and forward the packet appropriately based on IP routing table. Packets sent between the same endpoint might belong to different MPLS FECs and therefore might flow through different path in the network. So here you can see that what is that, how it is choosing its path. This path is for a data network and this is for voice network. They have decided. Now come to MPLS services. There are 5 different services for MPLS. First is traffic engineering. MPLS allows traffic to directed through a specific path which might be different from the least cost path determined by the IP routing protocol. This ability to define routes and resource utilization is known as traffic engineering. Then quality of services support. MPLS creates a connection-oriented network for IP traffic, thereby providing the foundation of quality of service traffic controls. For example, it might provide guaranteed bandwidth to a specific traffic between two locations. Then fast reroute, FRR, fast reroute. Because FRR allows extremely quick recovery from node or link failure, it prevents application from timing out and losing data. Then come to MPLS VPNs. Multi-protocol label switching virtual private networks or MPLS VPNs are much easier to deploy than traditional VPNs. They scale easily and increasing number of routes the customers and provides the same level of primary privacy as layer 2 technology. MPLS virtual private networks can also support non-unique IP addresses in various locations. For example, two organizations that use 10.0.0.0 private address space can be supported simultaneously. MPLS VPNs are also known as peer-to-peer VPNs. Okay. Then multi-protocol support. MPLS can be used in ADM network, a frame relay network, or a pure IP based internet. MPLS can be used to carry many kinds of traffic including IP packets and native ADM, SONET and Ethernet frames. So these are also supported by its frame format. The key for the designer of an MPLS WAN is to minimizing routing decision and maximizing MPLS switching queues. Means layer 3 minimization is there and layer 2 maximization is also there. Next technology is Metro Ethernet. Metro Ethernet uses Ethernet technology to deliver cost-effective high-speed connectivity for MAN and WAN application. Service providers offer Metro Ethernet service to deliver converged voice, video, and data networking. Metro Ethernet provides a data-oriented connectivity solution for the MAN and WAN based on Ethernet technologies widely deployed within the enterprise LAN. It also supports high performance network in the metropolitan area, meeting the increasing need for faster data speeds and more significant quality of service requirement. Where traditional TDM access is rigid, complex, and costly to provision, Metro Ethernet service provides scalable bandwidth in flexible increments, simplified management, and faster and lower cost provisioning than simple, easy to use technology appeals to customers who are already using Ethernet on their LANs. So this is the thing, and now let us discuss the next DSL technology. This is our next technology. DSL is very commonly used technology nowadays. Still, it is in use. So DSL delivers high bandwidth over traditional telephone copper lines. Okay, high bandwidth. This is the advantage of this. It works by way of two modems at either end of the wire, like dial-up cable, wireless, and T1. DSL is a transmission technology that enables service points to deliver wide variety of services to their customers. These can include premium high-speed internet and intranet access, voice, VPN, and video conferencing and video on demand services. Basic DSL implementation. The term XDSL, XDSL. XDSL covers variety of similar forms DSL. The two basic DSL categories are asymmetric DSL, ADSL, this is very common, and symmetric DSL, SDSL. This is very common technology in use. ADSL can be used only over short distances, typically less than 2 kilometers. So we are using this technology. ADSL is most common variety of DSL because ADSL operates as frequency from 100 kilohertz 100 kilohertz to 1 megahertz 1 megahertz that are above the voice channel 300 to 3400 hertz. ADSL allow PST and telephone services concurrently on the same line. So you can see that internet is there. Internet we are using, that is data service, and on the same line as a voice channel we use telephone networks also. So this is the advantage of ADSL technology. With ADSL, traffic moves upstream and downstream at different stream. For example, data that travel from internet to end user means internet to end user, it is higher. Suppose it is 10 Mbps, and the means it could be moving at 1.5 Mbps, while data traveling from end user computer to the internet, that is upstream, it may be, if it is 10 Mbps, it may be 1 Mbps. Okay, most of the time nowadays it is also same. While data traveling from end user computer to the internet, that is upstream, could be traveling at 384 kbps. Here I am showing 1 Mbps. ADSL can also provision for symmetric operation, making it viable residential and home office solution, as already discussed. And the learners of this course may have, some of the users may have DSL modems also. So what is downstream? Downstream is internet to end user. Downstream refers to data that travels from internet to end user computer, while upstream refers to data that travels from end user computer to the internet. With SDSL, that is symmetric DSL, traffic in either direction travels at the same speed over a single copper twisted pair. It means, here we are showing the example of ADSL. If we use SDSL for upstream also 10 Mbps, and for downstream it is also 10 Mbps. The use of single twisted pair limits the operating range of SDSL to 1,000 feet or 3048.8 meter or 3 kilometers almost. Unlike ADSL, SDSL does not allow concurrent PSTN telephony services on the same line. It means we cannot use telephone, voice channel and data channel simultaneously. Okay. It is a viable business solution and an excellent choice for running applications such as web and email servers. So for servers, we use these technologies. SDSL is sometimes referred to as single pair DSL. Now other implementations of DSL includes ISDN DSL. IDSL, it is very similar to ISDN. Next is high data rate DSL HDSL, delivers 1.544 Mbps of bandwidth each way. This is symmetric in nature, and over two pairs of copper twisted wire, data travels over two pairs of wires instead of one. HDSL does not support PSTN because HDSL provides T1 speed. Telephone companies use it to provision local access to T1 services wherever possible. The operating range of HDSL is limited to 12,000 feet or 3.6 kilometers. Now come to HDSL2. Second generation of HDSL is full rate only symmetric service. That is different from HDSL because it exists over single twisted pair line. HDSL2 was conceived specifically to provide spectral compatibility with ADSL. Now come to GH, GSHDSL. It combines the best of SDSL and HDSL version 2. So the standard defines multi-rate like SDSL but provides the spectral compatibility with SDSL2. Now come to very high data rate DSL. VDSL is an extremely fast asymmetric DSL technology that delivers 13 to 52 Mbps downstream. Okay, 13 to 52 Mbps downstream. It was very high at that time. And 2.3 Mbps upstream of data and PSTN services over a single twisted copper pair of wires. The operating range of VDSL is limited to 1,000 to 4,500 feet. That is not more than 300 meter to 1.3 kilometers. ADSL. This figure shows ADSL architecture and its design. It illustrates a typical ADSL service architecture. The network consists of customer premise equipment, the network access provider. This is the network access provider, and the network service provider. So network service provider and network access provider, all the things are associated with this diagram. CPE refers to end user workstation such as PC together with ADSL modem or an ADSL transceiver unit remote terminal. This is ATUR. The NAP provides ADSL line transmission, ADSL line, not line transmission, but ADSL line termination by using DSL access multiplexers. DSL access multiplexer. The DSL access multiplexer forwards traffic to the NSP. It forward traffic to the NSP. The local access concentrator, which is used by layer 3 termination. An ADSL circuit connects an ADSL modem on each end of twisted pair telephone line. This creates three information channels. What are the three information channel? Number one is data channel. Number two is means upstream channel, upstream, downstream data, and telephony services. So this is in a standard terminology, medium speed downstream, medium speed downstream. Okay, say 10 Mbps, and low speed upstream channel, say 1 Mbps. Okay, and basic telephone service channel. Fine. So voice plus data both are integrated in ADSL, and in case of data it is downstream data and upstream data. Filters or splitters split the basic telephone service channel from digital modem, guaranteeing uninterrupted basic telephone service even if ADSL fails. So this figure also shows a typical ADSL network, including from left to right customer workstation. This is customer workstation. Okay, and PC on a LAN, CPE, that is ADSL router. This is CPE. CPE is the ADSL router, or DSL AM on an ATM transport network. This is DSL access multiplexer on a ATM transport network. This is ATM transport network, and an NSP concentrator. This is NSP concentrator, and both packet and ATM core network. Packet and ATM core network. Two very popular point-to-point protocols implementations are point-to-point over ATM, okay, and point-to-point over Ethernet. Both the protocols are very common, and in DSL modem, while configuring DSL modem, we use triple PoE. Most of the time this channel we are using. Okay, so in point-to-point over ATM architecture, the CPE acts as an Ethernet to WAN router, and triple P session is established between CPE and the layer 3 access concentrator, the NSP. A point-to-point protocol over ATM implementation involves configuring CPE and point-to-point authentication information, login and password. In point-to-point over Ethernet architecture, the CPE acts an Ethernet to WAN bridge. CPE act as bridge. Okay, Ethernet to WAN bridge. Fine. And the triple P session is established between the end user's PC or point-to-point over Ethernet router and layer 3 access concentrator, the NSP. The client initiates a point-to-point session by encapsulating point-to-point frames into Ethernet frame and then bridging the frame over ATM or DSL to gateway router, the NSP, from this point. The point-to-point protocol sessions are established, authenticated, and address the client receives its IP address using point-to-point negotiations from termination point, the NSP. Okay, this is the termination point, NSP. This shows the ADSL point-to-point implementation. In previous figure also we have discussed the point-to-point implementation, but in this figure it is simpler format of point-to-point implementation. Here it shows in case of point-to-point over ATM architecture, the CPE acts like Ethernet to WAN router. Okay, and triple P session is established between the CP and the layer 3 access switch. From here to here, it is the triple P session. This includes the authentication information, login and password. In case of point-to-point protocol over Ethernet, the triple P session starts from the end user, and the this layer 3 access concentrator, the NSP. The client initiates PPP session by encapsulating PPP frame into an Ethernet frame and then bridging the frame over ATM DSL to the gateway router, the NSP from this point. The point-to-point sessions are established, authenticated, and addressed. The client receives the IP address using point-to-point negotiation from the termination point, that is the NSP. Okay, this is the NSP. Long reach Ethernet technology is Cisco proprietary technology that allows greater distances than the traditional Ethernet and is a WAN access technology. LRE technology enables the use of Ethernet over existing unconditioned telephone grade wire, that is copper twisted pair, using DSL coding and digital modulation technique. LRE technology allows Ethernet LAN transmission to coexist with POTS, ISDN, or advanced PBX signaling services over same pair of ordinary copper wires. LRE technology use coding and digital modulation technique from DSL world in conjunction with the Ethernet, the most popular LAN protocol. Okay. An LRE system provides a point-to-point transmission that can deliver a symmetrical full duplex raw data rate up to 15 Mbps over distances of up to 1 mile, or that is 1.6 kilometer. The channel's speed decreases with the distance. Cable technology. The cable technology for data transport uses coaxial cable media over cable distribution system. The cable network is high-speed copper platform that supports analog and digital video services over coaxial cable. So this diagram shows the remote access and internet service provider age, WAN core and PSTN, head and cable modem termination system, universal broadband router is there, and this is attached to a cable, and cable modem cable access router is there in left hand side at the remote access. This technology is a good option for environment where cable television is widely deployed. Cable service providers support both residential and commercial customers. This figure shows some of the components used to transmit data and voice on the cable network. The universal broadband router, that is UBR, also referred to as cable modem system termination system. So in this UBS, uh, provides high-speed data connectivity and is deployed at the cable company's head end. The UBR forward the upstream to connect with either PSTN or the internet. The cable modem, also referred to as cable access router, at the customer location offers support for transmission of voice modem and fax calls over the TCP/IP cable network. Cable modems are installed at the customer's premises to support small business branch office and corporate telecommuters. The UBR is designed to install a cable at a cable operator's head-end facility or distribution hub and to function as CMTS for subscriber and devices. The data over cable service interface specification, radio frequency interface specification, is defined the interface between cable modem and CMTS and data over cable procedures that the equipment must support. Upstream and downstream data flow. A data service is delivered to a subscriber through channels in coaxial or optical fiber cable to cable modem, installed externally or internally to subscriber's computer or television set. Geo is common example for that. One television channel is used for upstream signal from the cable modem to the CMTS, and another channel is used for downstream signals from CMTS to the cable modem. It was earlier technology. Actually, cable signal and data signals are connected together. Cable means the television signals. When a CMTS receives signal from cable modem, it converts these signal into IP packets that are then sent to an IP router for transmission across the internet. When CMTS sends signal to cable modem, it modulates the downstream signal for transmission across cable or across the optical fiber and cable to the cable modem. All cable modem can communicate with CMTS but not with other cable modem on the line. The actual bandwidth for internet service over a cable TV is shared at 27 Mbps on the download path to the subscriber, with about 2.5 Mbps of shared bandwidth for interactive response in other direction. So it was traditional technology. It is also Geo is just, you can understand that what is with Geo fiber, but it is Geo fiber is entirely different technology. What I am talking about, upstream and downstream data flow. CATV transmission. Before converting to their respective channel assignment in the downstream frequency domain, signals from broadcaster and satellite service are descrambled. Video signals are converted from optical signals to electrical signals. Okay, optical to electrical means optical signals are coming here and it is converted then into electrical signals and then amplified and forwarded downstream over coaxial cable for distribution to the cable operator's customer. Wireless technologies. So there are different wireless technologies available like bridge wireless, mobile wireless, and wireless LANs. So let us discuss each of them. With wireless technologies, network do not have the limitation of wires or cables. Instead, electromagnetic waves carry RF signals. So that's why its range is also very less. Common example of wireless equipment includes the cellular phone and pagers, global positioning system, cordless computer peripherals, satellite television, and wireless LANs. So in this figure, we can see that these are the technology. Now come to bridge wireless. This is the example of bridge wireless designed to connect two or more network typically located in different buildings at high data rate for data intensive line of sight application. A series of wireless bridges or routers connect discrete distant site into single LAN technology. So routers can connect discrete distant site into single LAN, interconnecting hard to wire site, non-contiguous floors, satellite offices, schools or corporate campus setting, temporary network and warehouse. Now come to mobile wireless. This also we are using in very frequent manner. Cellular voice and data application. Wireless technology uses increase with introduction of digital service on wireless second and third generation mobile phone offers better connectivity and higher speed. Mobile wireless technology includes GSM, that is Global System for Mobile. Global System for Mobile is digital mobile radio standard that uses time division multiple access TDMA technology. It allows 8 simultaneous cells on the same frequency in 3 different bands. These bands are 900, 1800 and 1900 megahertz. The transfer data rate is 9.6 kbps. One of the unique benefit of GSM services is its international roaming capability, a result of roaming agreement established among the various operators. Now come to GPRS system. GPRS extends the capability of GSM and supports intermittent and bursty data transfer. Speed offered to the client are the range of ISDN speed and it is typically 64 kbps to 128 kbps. It was very high speed at that time. Okay, then UMTS, Universal Mobile Telephone Services. UMTS is also known as third generation broadband service, packet-based transmission of text, digitized voice, video, and multimedia at data rate up to 2 Mbps. 2 Mbps. And UMTS offer a consistent set of services to mobile computers and phone users regardless of their location in the world. And now come to CDMA technology. It was also in connection with that TDMA technology. So CDMA was used by Tata and Reliance RIM Mobile. Okay. CDMA is a spread spectrum technology. It is sometimes used with BSNL also, but then it was discontinued. Okay. So CDMA is a spread spectrum technology that assigns a code to each conversation. Individual conversations are encoded in pseudo-random digital sequence. So now come to WLAN technology, wireless LAN. Deployed because of demand for LAN connections over air and often used for intra-building communication, WLAN technology can replace a traditional wired network or extend its reach and capabilities. WLANs cover a growing range of applications such as guest access and voice and support services, such as advanced security and location of wireless devices. So there are different standards. The IEEE 802.11g standard supports speed up to 54 Mbps in 2.4 GHz band, while 802.11b standard supports speed up to 11 Mbps in 2.4 GHz band, and 802.11a standard supports a speed up to 54 Mbps in 5 GHz band. So there are two bands with different speed and one more band with the higher speed. So we can use different WLAN technologies at required places. Synchronous optical network and synchronous digital hierarchy, SDH. Okay, SDH is very important, or SONET. So this is SONET and this is SDH. So let us discuss each of them. Synchronous optical networks or synchronous digital hierarchy, SONET SDH, is a circuit-based bandwidth efficiency technology. SONET SDH establish high-speed circuit using TDM frames. This uses TDM frames. So in particular, in actually SONET and SDH it uses TDM frames in ring topology over an optical infrastructure. Over an optical infrastructure, this figure shows the sample SONET SDH technology. It results in guaranteed bandwidth regardless of actual uses. Common bit rates are 155 Mbps, Mbps and 622 Mbps with a current maximum of 10 gigabit per second. So SONET is an ANSI specification and SDH is the SONET equivalent specification proposed by ITU-T, whereas European carriers use SDH widely. North America, Asian and Pacific Rim carriers use SONET more frequently. SONET SDH ring support two IP encapsulation for user interface, ATM and packet over SONET SDH POS, which sends native IP packet directly over SONET SDH frame. SONET SDH ring provide major innovations for transport and have important capabilities such as proactive performance monitoring and automatic recovery, self-healing via an automatic protection switching mechanism. These capabilities increase their reliability to cope with system faults. Failure of single SONET SDH link or network element does not lead to failure of the entire network. Optical carrier Rates are digital hierarchies of SONET standards supporting the speeds like OC1 supports 51.85 Mbps, OC3 supports 155.52 Mbps, OC12 supports 622.08 Mbps, OC24 with 1.244 Gbps, OC48 2.488 Gbps, OC192 9.952 Gbps, and OC255 supports 13.21 Gbps with a maximum speed. DWDM, dense wavelength division multiplexing. This figure shows the DWDM architecture increases bandwidth on an optical medium. This is also optical. Okay, DWDM increases the available bandwidth on single strand of fiber by using multi-channel signaling. DWDM is crucial component of optical network. It maximizes the use of installed fiber cable and allow new service to provision efficiently over existing infrastructure. Flexible add and drop module allow individual channel to be dropped and inserted along a route. An open architecture system allows the connection of variety of devices including SONET terminal. This includes SONET terminal, okay, and ATM switches, ATM switches, and IP routers, IP routers. DWDM is also used inside the SONET SDH ring. Dark fiber. Dark fiber refers to fiber optic cables leased from an service provider and connected to a company's own infrastructure. Nowadays, we are using dark fiber. Okay, but that time dark fiber was used for companies' own infrastructure. Dark fiber use here. It shows the dark fiber and regenerators are connected here. The framing for dark fiber is provided by the company's device and does not have to be SONET SDH. As a result, dark fiber connections eliminates the need for SONET SDH multiplexer, which are required in SONET SDH ring. The edge devices connect directly over the side-to-side dark fiber using layer 2 encapsulation such as gigabit Ethernet. When such connectivity is used to transmit data over significantly long distance, regenerators or DWDM concentrators are inserted into the link to maintain the signal's integrity and provide appropriate jitter control. Depending on the carrier and location, dark fiber might be available for sale on the wholesale market for both metro and wide area links at prices previously associated with lease line rental. So here in this lecture we have covered WAN Transport Technologies, which includes TDM, ISDN, frame relay, asynchronous transmission mode, MPLS, Metro Ethernet, DSL technologies, cable technology, wireless technology, SDH and SONET, dense wavelength division multiplexing, and dark fiber. So with this we complete. In next lecture we will discuss the last part of enterprise age WAN technology. So thank you very much. Bye bye. Have a nice day. Have a nice time.